Hi students, welcome to the class number 4 on trigonometry. In this class, I will discuss some examples on gradients and degrees. That means here we are going to learn how to convert degrees into radians and gradients into degrees, vice versa. So here is my example number 1. You can see here, convert 60 degrees into gradients. To convert degrees into radians, we know that 1 radian is equals to pi upon 180. So whatever the radians are given, multiply with pi upon 180. So 60 degrees means 60 into pi upon 180. So which is equals to pi by 3. So here 3 times cancelled. So result is pi by 3. So 60 degrees will be equals to pi by 3 radians. Because we know the relationship between gradients and degrees, pi radians will be equals to like pi radians is equals to 180 degrees. So come to example 2. The simple example I am giving, convert 45 degrees into radians. So by using 1 radian, pi by 180, so 45 into pi by 180. So here 4 times gets cancelled, which is nothing but pi by 4. So this is the way you can convert gradients into degrees. So here you can see the complete picture, which will give standard conversions of degrees and gradients. We can say standard result here. So 0 degrees, or which is also equals to 360, because initial line terminal line coincide. 30 degrees here, 30 degrees pi by 6, 45 degrees pi by 4, 60 degrees pi by 3, 90 vertical pi by 2, and 120 2 pi by 3, 135 3 pi by 4, 150 pi by 6. And when you come to here, pi radians means 180 degrees, half of the circumference. 7 pi by 6, that means 210 degrees, and 5 pi by 4, that means 225, 4 pi by 3, that means 240, and 270 another vertical. 270 means 3 pi by 2, and 300 pi by 3, and 315 7 pi by 4, and 330 11 pi by 6, and this is 0 degrees here. Once again we are landing at an angle 0. One complete round is finished. After that I get the same pattern once again. So this is the standard diagram given for degrees and gradients. So come to the next one, length of the arc. Length of the arc. So you can see in the picture here, r is the radius of the circle. R is the radius of the circle. Theta is the central angle. Then the length of the arc, nothing but L, or you can say S is equal to radius times angle at the center. So r times of theta, r times of theta. So let me give an example here. Example 1. So find the length of the arc whose radius is 5 centimeter and the central angle is pi by 3. Find the length of the arc whose radius 5 centimeter and the central angle is pi by 3. So length of the arc formula, L is equal to r times of theta. That means 5 into pi by 3. So pi by 3. So this is one example for length of the arc. In the same class, I would like to bring another interesting thing, linear and angular speed. Angular speed. So they play an important role in amusement parks, particularly giant wheels, and some particular rides are there. It has, say here in this figure, you can observe it has two rings. One is outer, no, that means more than two also maybe, but I'm taking two rings. One is outer, other one is inner. By saying this, I can say that both are at different linear speeds. Their linear speeds are different but have the same angular speeds. So to define linear speed and angular speed, here I am giving, you can see here, a point P on the circle with radius r moves at a constant speed of theta, where angle of variation is given by theta, with a given time t, so with respect to time t is given, then a linear speed, or you can say linear speed, v is equal s pi t, length of the arc with respect to time, that means divided with time. So units, revolution per second or minutes. Angular speed, omega is equal theta, theta by time, whatever the angle is given divided with time. So units are radian per minutes or second. So this is my fourth class on trigonometry. Thank you. In the next class, I will give some application based on this. Thank you.